again in Berlin to the Kamailio world. Yeah, quick view about the agenda. Yeah, just a few sentences about me, the motivation for this research that I have done. A quick introduction about fuzzing and the AFL fuzzer program. This is rather brief because yesterday we had another talk about fuzzing zip services. Then I want to describe a bit longer the necessary changes to the core and also to the configuration, the testing setup, more and more in like a kind of workshop description. So if you want to just reproduce this, this is probably helpful. We'll go over the testing setup and then show some example zip messages to really give you an impression how these AFL fuzzer works. And I will conclude with a summary and some further possible work. So about me, as Daniel mentioned, I'm since 2007, more than 10 years with the Kamailio project. Started with 1&1. As a developer, I worked in core databases and also different other modules. But I'm also involved in administration topics, like trademarks, some legal stuff, code quality, quality assurance, project management, stuff like this. I'm a senior IT manager. I worked in different companies in product IT, like 1&1, but also other companies. And I work on different side projects. This is one of my side projects. Some of them are paid, some of them are the way to give back to the community because I also received a lot from the open source community. Why I did this research? So I'm generally interested in security. I want to learn a long time ago about fuzzing with different tools. It's a really interesting approach. I did some research. I heard that fuzzing can yield to really great results, especially if you have like a structured protocol like HTTP or zip, where brute force testing is just not feasible. So I wanted to give it a try, basically. So what is fuzzing? This is just quoted from Wikipedia. I mean, you can, of course, look it up by yourself. But basically, what is fuzzing is that it's a structured way of software testing where you provide invalid, but only slightly invalid inputs to the program under test and expect that the program is behaving not normal. Maybe have some memory leaks, maybe did not return a proper message, maybe it crashed. This is, of course, the goal in this exercise. As I said, fuzzers are really effective for structured inputs. I mean, if you have a complicated program like Kamailio, just if you have a look to the parser, it's a really different loops interleaved into each other, basically. This is how the parser works, and with some string matching and then some state machines. So this is really not possible to test it in a brute force way because there are so many options. You will just run into many invalid states into the parser. So you need to have some kind of structured approach to test this. So what is the interesting thing about AFL comparing to just maybe writing some Python script or using a program, as Sandro from the security researchers yesterday showed, to just alter some zip messages. So AFL is really special that it somehow instruments the program under test. So you compile the program under test with a special compiler, and it adds some instrumentation to the program, like a debugger or profiler, and then uses this instrumentation, this knowledge about the program to really to exercise the test case against it and also to be more effective in this testing. So imagine you have like a if and else condition. A brute force fuzzer would just simply increment, for example, some characters, some integers, and will run into the same if case again and again and again. If you have a program like AFL, it knows, okay, this is the if and else case. We already have been in the if case. Let's try a different thing that we go to the else case. So it's really much more effective. So as I said, AFL, it tries to learn about the program and exploit it intelligently. They call it genetic algorithm. So far I didn't get why it's genetic. Maybe it's just a fancy name. Nevertheless, AFL was used to find a really impressive number of bugs in many, many core infrastructure parts like web browsers, email clients, libraries for JPEG, PNG, PostScript interpreter, all over the place. So it's really like a powerful piece of software. For the testing approach, it's like a white box testing approach because I have some input about the testing program as I'm a developer, but also the AFL program has input about the program under test because for the mentioned instrumentation. I used the version 2.52b. This is the latest version available, but it should work also with other versions. In the end, you need to download it and compile it locally because you need to compile also Kamailio with it, so it makes no sense to really use a package like from Debian or whatsoever. It's also not complicated. So it has a really nice, fancy, retro-style user interface. So it looks like this. I will show it later again, what all the different things means. It's a bit complicated, but maybe interesting for you at the moment is that it runs, in this case, when I took the screenshots, it ran over 52 days. It tested, let me see, some millions, where it is. It's a lot of information. In this time it tested over 114 million test cases, and this is the exec speed, so this is like slow because Kamailio it's a bit heavy, but I will also explain why it says slow. If you test just a simple library for images, for example, you will get maybe 1 or 2 orders of magnitude faster execution, but with Kamailio, because of the setup I have done, it's slower. So how you actually use the AFL to fuzz Kamailio? It's not working out of the box. This was also mentioned yesterday from Sandro. You need to do some changes. The changes are not trivial, but they're also not that complex. In the end, if you know a bit about C coding, know a bit about like system programming, I think you can do it. I haven't contributed this so far because it's a bit hackish. It's not suitable for inclusion at the moment. I did some hacks to really go forward with this research, but I plan to commit it to the code, master branch, of course. So basically, the major thing you need to change is that you process zip messages from a file system like standard input instead of the network. There is a fork of the AFL fuzzing program which works over network. I briefly investigated it, but it was a bit older, so I didn't go this path. So basically what you do, as I said, you connect the standard input instead of the network socket, and then execute Kamailio and feed a zip message to it. One of the mentioned hacks that I use was that I use some kind of magic character to signal the end of messages to really make it easier for the parser to parse the messages. This is just a hack, probably not necessary. It was just to speed up also the implementation. From a point of work, it was like maybe a few days of work with some breaks. So it's definitely doable to do this for a program if you are a developer or know C. As Kamailio is executed for every test case, this is the way the AFL program works. Of course, you want to make this as easy as possible for the AFL. So what I also did, I removed any unnecessary forking during the startup. So for example, in the test object, I don't start the RPC processes, I don't start timer, I don't start the TCP master process and some other processes. In the end, what I wanted to test was the core and the major modules. And then you can do also some other small optimization on the host machine. I will explain that later. AFL has also some optimizations for these for the forking and starting all the programs. So it has some kind of fork server structure. So it's rather efficient, more efficient than doing it by yourself, I would say. So if you have done this, you will need to compile the Kamailio with this AFL GCC. And we have also one module which is implemented in C++. So I also added the G++ alias here. So you just specify these aliases and then do make modules in the Kamailio. And then you have a Kamailio which is working, but it's also instrumented with this AFL code. Yeah. For the testing, I want to concentrate on a stock default configuration without any big changes, to make really like a meaningful test comparable to a setup that is also used maybe from yourself, which is used in the field. I still needed to do some changes, so I removed accountings at the moment. I didn't do net handling because it was not meaningful for these tests. I just want to test zip messages basically. Again, you need to start just one Kamailio process. This is something you also need to specify in the configuration with the number of children. And you want to restrict the memory usage because the memory needs to be allocated millions of times. And of course, then you need to give the no forking mode that you can actually feed messages to the standard input and get also the result on the standard output. This is another change I need to do. And then, you're set basically. You start the AFL fuzzer with the test corpus, which I explain in the next slide. So you give some memory limit, some timeout, some dictionary, which is just a way to add some domain-specific knowledge to the program. Again, I will explain this in the next slide. You will have some directory where it puts all the findings, and then the yellow part here is just a more or less standard Kamailio start command with a configuration file, modules, some temp directory, and then, I think without TCP and just one number of children and a no forking daemon mode, and some other small shared and private memory. So, and then you start it and you let it run over many days, basically. For the first days, it was more like an iterative development process, but then it was rather easy to just let it run. There's no maintenance or no things that you need to do. It's really stable, the AFL program. So where I tested it, so I let it run on my private workstation because this was the convenience for me. I started in November, therefore I also tested the Kamailio master branch from November. There were some breaks involved because of vacation, stuff like this, but more or less it runs like over 4 months. I didn't investigate like these parallelization and stuff like this, so you can start basically different AFL instances on your one machine. I didn't investigate it because it was my workstation. I also had some other work to do there. But of course this can be done if you have a dedicated machine, maybe a virtual machine or maybe a dedicated server somewhere. These are some additional kernel parameters you need to give. Of course, you want to have a core file. This is necessary for the AFL to auto-detect the crashes. This is some optimization I did just to be not that heavy to the I/O, to the hard disk or SSD. So this just means only write back the memory every 20 seconds, not every 3 or 5 seconds, which is the default. So basically, in theory, it's really heavy to the hard disk or SSD, but in the end, as most machines have quite a lot of memory nowadays, it will cache almost everything. So it will not write that much requests to the hard disks. And then you need to deactivate the power management more or less to the CPUs because it didn't work really well with this automatic power management. So you will need to give him the performance governor for your kernel, basically, and that's it for the system configuration. For the test corpus, of course, you need to give him some messages to make the test process also shorter. So what I did was I just created 4 simple zip messages from zip-p, 1 invite with an invalid content length, 1 invite that should result in a 404, 1 invite that should result in a 100 trying, and 1 register with a new contact. Basically, that was it. So this is like a start point, and then AFL will use this as a start point to get on with the process, and then I will show you later it will find some new supported methods, some new supported zip messages on the way. And the second thing you need to give is a zip dictionary. In this case, I created a dictionary with about 50 to maybe 60 entries. So what I included here was the main zip method names, of course these magic strings like these Z9, H, etc. for transaction matching, some IP addresses, some other keywords basically from the standard, from the 3261 standard. Okay, so these were all the preparations. Now I want to give you some zip messages how it actually works, because in my opinion it's rather interesting how this program works. So this is like a starting point. You see here the ID in the first sentence of the slide. This is the ID 03, and then in the next 20 slides or so, I will just show how the fuzzer will iterate and modify the messages and try the different cases in the parser. So this is now a second step, ID 1441. The source ID was 3, so it's everything source, and then the actual ID. So here it notice that it can modify the IP addresses. In this case, it makes it invalid, and it will have a different state in the parser. Another change here, it modifies the IP address again with a port, finds that there's another path in the core that it will execute it. Yeah, it modifies again here the port. The other, more like words, op flip 1, post 23, etc. This is some code works for the operation that AFL has done in actually modifying the messages, but you can ignore it. It's more like really details. So in the fourth step, it found by himself that like a register to the local host is somehow processed differently, like a register to an invalid or like a not local host address. This is something the AFL fuzzer found by himself. I didn't give him this information. This is something interesting. Yeah. Then it tests some random permutation about the transaction cookie here, do some transponations here just to test the parser. Just highlighted again as yellow the changes. And then after a long time, it really found some new states in the parser by just permutation of the messages. So the next few slides are just showing some more and more invalid messages. You can see somehow it's playing with the zip UI, request UI, sorry. It gets even more crazy, but this is all fine for Kamailio. It doesn't really crash, makes no sense, makes no issues. Yeah. Now it here plays again with some messages, inserts here some messages and whatsoever. Yeah. Okay. Then this is something interesting. You can see it founds an M, it founds an A, it founds an D. Here it somehow changes the method name, I don't know. But in the end it found the second D, and it recognized that there's some special keyword MAADDER, which is in the parser and which is recognized. So it really like goes to the parser and finds the different stage which can be executed. So it's rather interesting. So and then this is the last step. So it was like over 22 different steps, which it's drilled more deep down in the parser, in the modules. And here it found that like the configuration and also the modules recognize another keyword, another request, of course, options. So I didn't give this to him, so it's really like found it by himself. This shows that it really tries to understand the program under tests. Okay. So if you get some results, all these results are really nicely summarized from the AFL. I will show the nice GUI later again. For a big picture for you, it's like what we all know, Kamailio is really, really, really stable. So I tested over 310 million test cases, basically, and with this really targeted approach, which really tries to execute and be really malicious to the parser, and it just found basically seven major different crashes, more or less. So it makes like an error rate like 1 in 44 million, which is amazing. I mean, yeah. This is really like when we're talking about like this is really like a carrier grade software, I would say. This is really the error rate which we are looking for. Yeah, a bit more statistics. So I finished a complete exhaustive test cycle. So what it does, it really goes to all the different paths, and then after a while, it didn't found any new passes, and then it will say, okay, we finished the first test cycle, but it will continue to run because in the end there are some random permutations going on. So there's still the possibility that it finds new passes, but it still needs some more time then. So like the level 22, which the depth more or less what I reached here. It tested over 10,000, almost 11,000 different code paths in the core and in the modules. And additional to the crashes, I found over 500 individual hangs. A hang is like a timeout, a condition where the server should respond with the proper error messages, but somehow can't respond to it. And there are some valid reasons, of course. I mean, if the message is really broken and there are some headers that are necessary to create a response are missing, then in the end, we really can't create a response. But this is something really I want to investigate more. There are probably some cases there which can be fixed. But this is not that critical, of course, with the SE crashes. So again, this is the overview about the AFL output, the graphical user interface, more or less. So what is really effective in fuzzing Kamailio? You can see here the operations, basically. So the first number is the number of code paths that were found, and the second number is like the number of iterations that were executed to find these one. You can see like bit flips, just simple bit flips are really effective. Also, arithmetic operations are really effective. Byte flips, not surprisingly, are not effective because in the end it's a text-based protocol. So if you flip a complete byte, it will not really change that much. But if you flip a bit, then you alter the character, it will have some meaning to the parser. It will create a new state. This havoc, which is just basically a random permutation of the messages, which this was really effective, especially if you look to the just 1 million of execution here. Yeah, and this is the dictionary. Basically, here you can see. Yeah. Another thing it does, and what AFL does is, additionally to the given dictionary that you specify during startup, it tries to automatically create a new, more dictionary elements for that. For example, I showed earlier the MADDR keyword, which is recognized in the parser. If it found something like this, it will add it to the dictionary and then use it later in some more fuzzing steps. Yeah, you can see here like some statistics about the code coverage that we went through, like over almost 30% code coverage in all the passes. This is quite good, I think, because in the end, I just tested invite and register, not some fancy subscribe or whatsoever messages. And this here is the number of paths that were found and the test where it thinks where it is in the test cycle. Yeah. This is the stability. This is also maybe interesting for you. This is over 99%. This is basically the stability of the execution. If I execute the same program 2 times, do I get the same result? So, and this is really quite good. There were some issues during the beginning of the test run, but then this was more or less fixed in this. Yeah. Here you get the summary of the overall results, 7 unique crashes, over 500 plus hangs or timeouts, but these are the interesting interesting number. Yeah, so I was really happy that after some time, some weeks ago, I found really one crash in the core. Yeah. In the end, it's a bit of a guessing game, or some luck is of course also involved. If it's running, you can just hope that it finds something. But I was really lucky that I found a bug, a crash in the core message parser. We don't have that much from them anymore. It's really like from a security or like an exploitation point of view, it's a really nice bug. It's stable and immediately with just one UDP message, and it doesn't matter what module you have in the configuration which are executed the parser. So I tried it with different modules, sanity or register or stuff like this, and also on different versions, and it really crashed reliably. I didn't publish the details today, sorry for that, because the fix is in the public repository, but it's not yet in a public release. So I don't want to, yeah, of course, let you in the cold specifying the message here. You need to have some time, of course, to patch the systems. It is available in the master branch and also in the maintain and stable branches, of course, as usual. And it will be, of course, included in the next minor releases, as usual. So I will publish more details about the message, I think, yeah, then after the releases. It is related to the registration module, some special configuration with the headers, but I won't give more details on that here, sorry. Okay, yeah, for summary, I think that fuzzing with AFL especially is effective if you get a bit over the learning curve in the beginning. It can really find these rare and critical bugs which we're looking for, which are really critical, these crashes in our core. The setup is like nothing for like a Windows script kiddie, I would say, but it's doable, but it's not doable, sorry, this not is of course redundant, but it's doable for a motivated hacker. Just you need some time to really figure out how to interact with the core. In my opinion, it would be beneficially if we can further work in this area to protect our infrastructure. This would be really helpful because in the end, if you are a motivated hacker and if you are out to get some bugs in core infrastructure like Kamailio, you will find it if you have enough motivation and enough time, money available. In the end, this was done for me as a side project. I'm not like a funded hacker from somebody. So if you have some time, you will find some issues, and this is something we should protect against it. So further possible work, one thing I plan is to let AFL run continuously in the future on a dedicated machine. So now the setup is stable, just need to update it against the latest master. We have some spare machines available. Daniel mentioned yesterday, I think I can configure it there. After we did the release, the minor releases, I will import the code and also the test suite to the Kamailio Git repository. So the result of the AFL, beside from the crashes, a really nice test suite with over 10,000 different code passes that can be executed in a parser or in the core modules. This is something beneficial. I think we should also execute frequently, just as a regression test, maybe as a release test, stuff like this. Then it would be, of course, also possible to cover more modules, maybe presence, maybe dialog. You'll probably find some issues there. And of course, you can also fuzz RPC interfaces or like database interfaces and stuff like this. So anybody who's interested in supporting this work, I would be happy if you can contact me. I'm really interested in continuing this. It's a good way in protecting our infrastructure, I would say. And it's much more effective than just brute force testing or relying on luck, what we are doing more or less in the past to really find the issues. Okay, that's all from my side, and thank you for your attention.
Thank you, Henning. So, Andreas is preparing, and we can take 1-2 questions as Andreas gets to the front and Any question here? Any questions? If not, one from my side. Yeah, you said you are happy finding a crash.
Well, this was the goal, sorry.
No, I'm happy you found only one. But yeah, this you said there are some changes that we need sometimes to do to make it a bit more friendly for this. So how you think we should integrate that, making like a requirement somewhere, or we do it from time to time like a review, or?
I think, as I mentioned,